Do the potential benefits of synthetic biology outweigh the possible risks? What is synthetic biology? Synthetic biology is an interdisciplinary field of study that combines biology, chemistry, computer science, and engineering in order to make new or redesign existing biological systems and components. While there's no widely used definition of the field, there are commonalities that exist when explaining what synthetic biology is. Some of those include it's a discipline that brings together the insights and methodologies of computer science, engineering, and biology. It encompasses genetic engineering, pharmaceutical manufacturing, and molecular chemistry. Unlike natural biological systems that begin in nature, synthetic biological systems begin in a computer. Synthetic biologists have two main goals. One is to build new life forms assembled from their fundamental chemical components, and two, to use biotechnology to produce substances that are otherwise difficult to obtain. Advances in the applications of synthetic biology can revolutionize and possibly eliminate current and future world issues. Ethical questions and dilemmas. By creating new life forms, does this imply that man is playing God? Or by engineering new life forms, are we going against the sacredness of life? Or would this change our general understanding of morality? People who care deeply about the environment would argue that synthetic biology undermines the value of nature. An example of synthetic biology. Malaria is a mosquito-borne disease, most prevalent in poor countries with tropical climate. According to the Center for Disease Control, malaria is one of the most severe public health problems worldwide, though there is no global vaccine. It is the leading cause of death in most developing countries. Most fatalities are those of pregnant women and young children due to their decreased or underdeveloped immunities. Individuals with symptoms of malaria should be treated early. However, this has proven to be challenging for countries with limited resources. Treatment for malaria includes an ingredient known as artemisinin, which is found in the plant sweet wormwood. Artemisinin was found to have a 100% success rate in the treatment of nearly all strains of malaria, but it takes months to grow and harvest. According to the American Botanical Council, artemisinin availability and global supplies are low due to several factors, including the 6 to 8 month period required to cultivate sweet wormwood, followed by several more months needed for extraction, processing, and manufacturing. These factors are not only time consuming but also costly, which makes it unaffordable for the people who need it most. However, using methods of synthetic biology, Dr. J. Kiesling, professor of chemical engineering and bioengineering at the University of California, was able to develop semi-synthetic artemisinin. The process involved identifying the gene for artemisinin, replicating, synthesizing, cloning, and then purifying it. The final step was honing it for large-scale production. This created a cost-effective and reliable source of the drug. According to twistbioscience.com, as of 2015, 15 million treatments have been made available in nations severely challenged by malaria outbreaks. Potential benefits. Synthetic biology poses benefits in areas such as medical, agriculture, environmental, and energy. We can hope to see ways to diagnose, monitor, and treat diseases such as cancer and diabetes. Also, we can hope to see the development of more efficient vaccines and medicines. As for agriculture and environmental benefits, we are facing food shortages and the destruction of our crops due to environmental threats. With synthetic biology, scientists can develop ways to avoid crop disease, make foods last longer, and have a greater nutritional value. Alternative uses of energy can be found through means of synthetic biology. While there are potential benefits, there are possible risks. Some of those include social and economic injustice. Synthetic biology will bring about a new industrial age, which will prompt a shift in the production processes of certain goods and services. This could possibly result in a loss of jobs and a monopoly on intellectual properties. Biosafety. Because synthetic biology involves living organisms capable of growth, mutation, and reproduction, it is important that they are handled carefully, lest they are accidentally released into an uncontrolled setting. According to our text, this could pose a threat to public health, agriculture, and the environment. Purposeful misuse. It is a fear that organisms may be weaponized or can be weaponized. It is clear that the potential benefits of synthetic biology outweigh the possible risks. Curing disease, healing the environment, and creating resources where there is a need are some things the world can benefit from as a whole. Much of the opposition towards this field of study focuses on the means rather than the end. By creating living organisms, are scientists mocking God? Considering the means by which scientists create these organisms, it is hardly an imitation of how the world was created. Synthetic biologists simply use what is already available to us from nature and expand on it. Our current biological systems serve as a foundation for advancement and adaptation. If not, the world will still be as it was when it was created. Accepting synthetic biology does not mean life is less sacred or that technology is more valuable. Instead, we are using it for its intended purposes. Without scientific advancements like synthetic biology, people will live miserable lives in the future. Scientific advancements like synthetic biology provide a means to an end for things that threaten our well-being. The atmosphere is deteriorating and resources are becoming scarce. This is due in part to human interaction in nature itself. As rational beings, synthetic biologists are identifying problems that the world is facing and making attempts to solve them. The possible risk can be mediated through government oversight and limitations. Governments can use extensive screening processes for employees who work with sensitive information, create security protocols and contingency plans to ensure safety. If we can create organisms, surely we can destroy it. In the event an organism is weaponized, a plan of action should be in place to destroy it. Lastly, just as there is a World Peace Organization or a World Health Organization, there can be a World Synthetic Biology Organization that oversees the use of synthesized organisms.